Bright Duty. Every student matters.
Hello children, welcome to the session. So in this session children, we are going to discuss about a few questions and answers from the topics that we have covered so far. So the first question is children, give an activity to show the heating effect of electric current. So children, first of all we will see if it is asked for a 3-marker question, or is it a 5-marker question, or is it asked in 2-marker. If it is asked as a 2-marker question, then you will just give a simple activity wherein you will give a simple circuit diagram where you just have a cell represented by 2 parallel lines, the longer one representing the positive terminal, the shorter and thicker one representing the negative terminal. Then children, we can connect this to a cell, making a coil and enclosing it within a circle. Then we will connect it with a switch, and finally the other terminal will connect it to the positive terminal of the cell. We will show a simple circuit like this. We will ask you to switch it on and switch it off after 2-3 minutes, and then touch the bulb. You will observe that bulb has become heated or it has become hot, right? And now you will keep it switched off for some times, and then you will touch the bulb, then it will be resumed, and then it will be cool again. So this proves that this proves the heating effect of current, that is the bulb has become hot only for the duration when the current was flowing through it. Okay, so the heat produced is a result of electric current. So this is the simple activity which you can give if this question is asked for a 2-marker. Now suppose children, if this question is asked as a 3 or a 5-marker question, and since it is asked in the form of an activity or an experiment, so you will first give the aim of the experiment, which is to show the heating effect of electric current. Then you will write the materials required. What all will be the materials required? We will be needing a cell holder, we will require 4 cells, we will require a switch, and we will be needing a nichrome wire. Okay children, so let us see how we can make the setup for this. First of all, we will make a cell holder. We will recall the steps in which we can create a cell holder. We will take a wooden block. We are going to place 2 metal strips, and we will ensure that they are tight by placing a rubber band over the 2 metal strips, and we will connect the 2 ends of these terminals with the connecting wire. Okay children, now we will place 4 cells in this holder. Okay, and now we will place a switch over here, and here we are going to place a nichrome wire. This is the nichrome wire. So now when we will switch it on, we will switch it on for 2-3 minutes and then switch it off. And after switching off, we will touch this nichrome wire, and we will observe that this nichrome wire has become hot. Now we will keep the switch off for few minutes and again touch the nichrome wire, and we will observe that it has become cool again. Okay, so children, we can repeat this activity 2-3 times to make sure that the wire becomes heated only when the current flows through the wire. Okay children, so this activity proves that the heating effect of electric current. This activity proves the heating effect of electric current. So let's move to the next question. What is the heating effect of current? So children, how do you define the heating effect of electric current? So children, it is the heat produced whenever the current flows through a conductor. So whenever the heat is produced, whenever the current flows through a conductor, we call this effect as the heating effect of electric current. Okay, and for example, you can give the example of a bulb, that if you will light a bulb for 5 minutes and then switch it off, and after switching it off you touch it, you will observe that the bulb will become hot. Okay children, and this is due to the current which was flowing through the bulb. Okay, so let's move to the next question. On what basis the production of heat due to electricity depends? So children, what are the factors on which the amount of heat produced depends? So children, the amount of heat produced depends upon the nature of material, that is what is the type of material we are using. nature of material, that is whether we are using a copper wire or we are using a tungsten, nichrome, or for that matter if we are using simple steel wire. Okay, then second, it depends upon the length of the wire. What is the length of the wire or the conductor that we are choosing. Then finally, it depends upon the thickness of wire. It depends upon the thickness of wire. So these are the three factors on which the amount of heat produced depends. Okay, so let's move to the next question. Give examples from daily life where you can see heating effect of electric current. So children, what all can be the examples? For example, whenever you switch on an electric bulb for few minutes and you touch it, you will observe that it has become hot, and when you will switch it off for 5-10 minutes, you will touch it again and try to feel the surface of it. You will feel that it has become cool once again. So this proves that there is heating effect of electric current. Okay, let's move to the next question. How do also children, we can observe from the daily life that there are certain appliances like geyser or electric heater, hair dryer. These are all the appliances, children, where the heating effect of electric current can be seen. Okay children, so let's move to the next question. Next question is, how do appliances like room heater or hair dryer produce heat? So children, you might have seen these devices like room heaters and hair dryers, and they produce heat when we connect them to a switch or to an electric circuit. Okay, so how do they produce electricity? They produce electricity because they produce heat, children, because they have coil inside them, and this coil, whenever the current passes through it, this coil become very hot, and we can use this heat produced for our purpose. For example, hair dryer, or for example electric press. Okay children, so they have this coil which we call as element, which becomes heated whenever the current passes through it, and they give us heat energy. Let's move to the next question. Can you see the coils on the devices like hair dryer or an iron? So children, can you see the wires or the coils on the surface of them? No, you cannot observe this on the surface because the coil is inside the appliance. When you can observe it if you take it to a repair shop and the shop owner opens it, and you can observe it inside that there will be so many coils, and because of these coils or the element, these appliance gets heated. Element, we call these coils as elements. Okay, let's move to the next question. Why do the wires used in electric circuits do not become hot? So children, we have been doing so many activities, so many experiments, yet the copper wires or the connecting wires that we use to make the circuit do not become hot. And the reason behind this is, children, because the copper is a good conductor of electricity, and it offers no resistance to the flow of current. What is the resistance? Resistance means obstruction. Since the copper is a good conductor, it won't offer any obstruction to the flow of current, and current will flow very, very nicely through this wire without producing any heating effect. Okay children, so you can observe this is the place where the nature of the material comes into play. So the nature of material which we are using is copper, and its nature is that it is a good conductor of electricity. Right children? So in case we need the wire to be heated, or we require high amount of heat energy, then we'll have to replace this material with some other material which can get heated fast. Okay, let's move to the next question. What is an electric fuse and what is its principle? So children, an electric fuse is a safety device. It is a safety device. It protects our devices from the excessive supply of electric current, and its principle is, it is based upon the heating effect of electric current. It is based upon the heating effect of electric current. Okay children, so this was all about the electric fuse. Let's move to the next question. What are the different types of fuse? So children, these days two different types of fuse are available. One is the ceramic fuse, and the other one is the cartridge fuse. Cartridge fuse is used in the expensive electrical appliances, whereas ceramic fuse is used in the buildings. Okay, and also these days children, MCB is used, which is also a type of a fuse or a safety device. Okay, so let us see the diagrams for these. So ceramic fuse looks something like this, and cartridge fuse looks like this. Okay, so let's move to the next question. What are the reasons for the excessive flow of current in a circuit? So children, what is the reason behind the flow of excessive current through an electric circuit? So children, basically there are two reasons. One reason can be short circuit, and the other reason can be overloading. These are the two main reasons for the excessive flow of current. So what is short circuit, children? So children, sometimes what happens is, due to wear and tear, the insulation from the wires is removed. Okay, and these wires might be touching somewhere, and this can cause short circuit or the excessive flow of current. Okay, and this is the main reason for fires. Okay, and one more reason is overloading. What happens is, children, sometimes we use so many devices in a single socket. Okay, and in this case there is overloading of the current, and it will lead to the excessive flow of current. Okay, single socket. So these are the two main reasons for the excessive flow of current in the circuit. So let's move to the next question. What is miniature circuit breaker? And most of the students gets confused. What is a miniature circuit breaker? So it is nothing, children. We have studied about MCB, right? It is also similar to the fuse, electric fuse. The only difference is we cannot see the wire breaking. The wire does not actually breaks. What happens is, there is a meter, and it is automatically switched off whenever excessive current is passed through it. And after this happens, all you need to do is just switch it on, and the circuit will be complete again, and the current will flow properly. So if we can just show you the diagram for this MCB, you might have seen this at your houses, right? This is MCB or miniature circuit breaker. Okay, children. So children, we have next question, which is how we can reduce the wastage of electricity because of a bulb. So children, why is there a wastage of electricity in electric bulb? Because you can see, whenever we switch on the bulb and we'll switch it off after some time, say after 5 minutes, and switch it off, and now you touch this bulb, you will observe that it has become heat. So children, is this heat desirable? Do we really need our bulbs to produce heat for us? No, we do not need this heat energy. So what we can do is, we can replace them with CFLs or the fluorescent lights. Okay, children, and these fluorescent lights can reduce the wastage of electricity to a greater extent. Okay, children, so in this way we can reduce the wastage of electricity. And this was all about the topics from the this was all about the questions which we had to cover from the topics that we have covered so far. So thank you, children, for your attention.